Hello, hi everyone. Welcome back. I am Shobik Ghosh, a senior CPU design verification engineer, currently working at Synopsys for more than 1 year, around 1.2 years. So prior to this, I have worked in Intel Technologies for more than 2 years, 2 years, 2 months as a CPU design verification engineer. And prior to that, I did my MTech from IIT Kanpur, electrical department. And I have I have studied subjects like VLSI and all, and I am passionate about the verification industry, VLSI design and verification industry. I am passionate about digital design and different like computer organization and architecture and Verilog, system Verilog, etc. So currently, what I am doing is the HDLBits problem solving walkthrough. So basically, all the HDLBit problems I'll be solving one by one and showing you how to solve them. Okay. So what you can do is you can try the problems first, as I have already told you previously. Try the problems first, and after that, if you are not able to solve, okay, please do let me know. Uh, that if you have any doubts, please do let me know, and I'll be sorry. Just a minute. I'll just come in. Just a second. Yeah. Sorry. Uh, So try to solve these problems first yourself. And if you're not able to solve, you can see this walkthrough. And if you have any doubts after seeing this walkthrough, please do write it in the comment section. I'll be happy to solve it. And if it's a big doubt, I'll make a video on it, trying to solve it. And because it's a YouTube video, I usually speak in English so that it's common for everyone. Everyone can watch it and understand it. But if you want personalized communication or guidance, personalized counseling, okay, you can like register for a one-on-one. You can contact me and we can take out some time to meet, and I can know you. And yeah, based on whatever help you need, you can let me know. Okay. Okay. So let's start with the problem solving. I'll share my screen. And please do like this video. Okay, share this video and the playlist with your friends and subscribe to this channel. It motivates me a lot. And if you want, you can also contribute. Okay, so it will be very helpful to me. So what I'll do is, let's go to the problem where I stopped before. Okay. Okay, great. So we have covered till this. So let's start with this K-map implemented with a multiplexer. Okay. So we have this problem. So what we will do here is we have to make, let's say we have the following Carnot map, following K map. give the circuit implementation. Okay, we have to give this circuit implementation using 4 to 1 multiplexer. Okay, we need to have a 4 to 1 multiplexer and as many 2 to 1 multiplexers as required. Okay, 4 to 1 multiplexer we have here and as many 2 to 1 multiplexer as required, but by using as few as possible. You're not allowed to use any other logic gate and you must use A and B as the multiplexer selected inputs as shown on the 4 to 1 multiplexer below. So this is a 4 to 1 multiplexer. A and B are the select lines to this 4 to 1 multiplexer. You are implementing just the portion level top module. What we will implement is just the portion level top module. So this is what we need to implement, this black box you can see here. Okay, such that the entire circuit implements this schema. Okay, so now what happens is, if you see, if A and B is 0 0, if A and B is 0 0, okay, what it will pick is this input is given to the output. A and B 0 0 means this input is given to the output. 0 1 means this input is given to the output. 1 0 means this is given to the output. 1 1 means this is given to the output. Okay, as simple as that. Now we have to define or make a circuit where if AB is 0 0, we give this to the output and we get the value of C and D here. So what is based on the values of C and D, this F will be decided. So if A and B is 0 0, what is the circuit here? So let's make this. Okay, let's prepare this in a paint. Let's show you how it should be done. Okay. So what or how we will do it is, we will say, okay, so okay, so when A and B is 0 0, okay, what we have is, let's say if I take 0 0, we can create a small K map here. Okay, we can create a small K map of C and D. Okay, now what we see here is, it's like uh, 0 1. So C is 0. For C is 0, what we have is 0 1. Okay, for C1, what we have is 1 1 1 1. If I do this, then what we have, out equal to, or f equal to, or what we should say, mux in of 0. Okay, this we will give as mux in of 0 is equal to c plus d. Okay, this is c plus this is d. I mean, this one is c and this one is d. Okay, literals. So c plus d. So what we will implement is assign okay, so I'll solve it in two ways actually. They said use mux. What we will do is I'll just show you this logic is correct. Mux in of 0 equal to C or D. So I'll show you this intermediate steps that okay, these are also correct. Then we will go ahead, move ahead. Okay. What we will do here is I'll say a b equal to 0, 1. So in case of a b equal to 0, 1, what we have is in case of 0, 1, we have mux in of 1 equal to 0. So you see a b equal to 0, 1 means everything is 0. So we can say mux in equal to 0. Mux in of 1. Okay. For a b equal to 1, 0. 1, 0 means this line. What we have is we group this and this basically. You know? Why we are grouping these two? Because I am just taking this column. Or what we can say is a b equal to 1, 0. Let's take what is this. So this column only we need to look. So 0, 0. So c bar d bar plus c d bar. If I take common d bar, it's like c bar plus c, which is 1 into d bar equal to d bar. Or what you can do is you can just take this and this. So what this gives is AB10 and D bar. So it's like A B bar D bar. Okay, so A B bar is 10. So I am saying if given A B bar, what is the other value? D bar. Okay. So of 2, so mux in of 2, mux in of 2, mux in of 2 is D bar. Okay. Now what we need to find is A B equal to 1, 1. In this case, what happens? In this case, we have CD equal to 1, 1 is 1. Means mux in of 3 equal to CD. Okay. Mux in of 3 equal to CD. So let's implement that. I'll just copy this. And then we will convert it into mux. the mux in of 1, 2, 3. Okay. For 1 we have 0. For 2, which is 1 0, we have d bar, which is like not of d, and here we have c and d. And if I just submit, you will see the answer is correct. Okay. Okay. So let's submit and see what is the result. After that, what we need to do is we can just convert it to mux. Okay. The status is success. Status is success. So it's a correct thing what we have done here. Okay. Now how to convert this to mux? So let's say we have a b equal to 0 0. In that case, mux in of 0 should be c or d. Okay. How to write it? You know, using a mux. So let's take a mux. Okay. And let's give, you can give either C or D as input. I mean, as a select line and the other as input. So let's say I give C as a select line. Now, if you see this, what you can see is if C is 0, you can see if C is 0, then what is the output? Output equal to D. So it's like 0, 1. Exactly same. Okay. I'll show you. Let's say I'll show you using K-map. That's a good way to show. Actually, it's the same thing. You can visualize in 100 different ways. Let's say C and D. 0, 1, 0, 1, 0, 1, 1, 1. So this is the K-map. So what you can do is you can say in this mux, I give input, select line as C. So when C equal to 0, this is selected. So what is this? This, if you see, this will either represent 0, I mean, which is 0 0 or 0 1. So if this is 0 0, then we say the output is 0. Basically, the input should be 0. Okay. If it is 0 1, that means it is equal to D. 0 1, same as D. D. If it is 1 0, I say it is just opposite to D, which is D bar. Okay. And if it is 1 1, then I say the input is 1. So it's like if I give 1, then it's like output is 1 1. Okay. So what I will do is 0 1. So I'll say that okay, it is equal to D. So whatever I have in D, that I will get at output. So when C equal to 0, if D equal to 0, I get 0. It's like C equal to 0, D equal to 0, I get 0. When C equal to 0, D equal to 1, I get 1 in the output. Okay. So this is what I'm trying to explain. This input will be D. Okay. And when C equal to 1, I have 1 1, which is, give like giving 1 as an input. So it's like when C equal to 1, this is given to the output. What is given? 1 always. No matter what is the value of D, we always get 1 when C is equal to 1. Okay. So this is mux input of 0. What I am doing is mux input of 0. What I am saying is mux input of 0. I am saying if C, okay, I am checking the value of C question mark. If C is 1, if C is 1, what I am giving? 1. 1 tick B1. Otherwise, if C is 0, what I am giving is D, else D. So what I am saying, C is 1. If yes, output is 1 tick B1. Otherwise, D. Okay. You can do the same thing using in case of A and B equal to 0, 1. What happens is mux input equal to 1 input of 1 equal to 0. Okay. Now what you can do here is you can say let's consider there's a mux C output and input. So when C equal to 0, this is selected. When C equal to 0, what is selected? Let's say when 0, 1, AB equal to 0, 1. So we should look at this column. When C equal to 0, output is 0. Output is 0. Whatever is the output, that is what we will give in the input, right? When C equal to 1, okay, what is the, sorry, what we should check is this column 0, 0. So here also we have 0. So we are giving 0 to the output. Okay. So no matter what is the value of C, this will be 0, 0. So what I will do is, no, if I can write like this, in the same format. I'll say C, if yes, 1 tick B0, otherwise 1 tick B0. I mean, I'm just writing in the way it is asking. Similarly, you check here. Okay. What you will see is when this is 1, 0, AB equal to 1, 0, the third one. When C equal to 0, these two, what you see is D is 0, 1. It is 1, 0, which is D bar. D bar. Not of D. Okay. Otherwise, we have 1, 0, but here we have 0, 1, which is again not of D. Okay. When C equal to 1, we are selecting this two. We are selecting this two, which is not of D. So this is 1, 0. This is 0, 1. Again not of D. No matter what is the value of C, we are anyway selecting not of D only. And here what we have is when C equal to, so this is this one. Okay. What you can do is when C equal to 0, output is 0. When C equal to 0, output is 0, one tick B is 0. When C equal to 1, you need to look here. It's like D. Whatever you have in D, you are getting exactly 1 0. Okay. So you can say output is D. Got it, right? You can do this way also. So now it's running. You can see what is the output. Okay. So you will see a success. Oh, incorrect. Give me a minute. I'll just check. One tick B0, one tick B0. So C, if C is 1, it is one tick B1. Otherwise, T. I think I did a mistake here. I should put D here. I mean, we should give one value here and the 0 value here. That is what I did mistake. Okay. So it's like if C equal to 1, output is D, otherwise output is 0. Okay. If you now submit, you'll get the correct output. Okay. See, success. So that's the mistake we did. So when C equal to 1, whatever is should be the result, we should give it here before the colon, not after the colon. I gave like 0 1 because in marks we have 0 1. After 0 we have 1. Here we have like 1 0. If C is 1, we give this, otherwise this. We implement it in a kind of, what should I say, opposite way. Okay. Okay. So I actually understand this problem. I explained you, but I don't know how much it will be clear to you. So each and everything I tried to explain in different ways. So each and every, so for a b equal to 0 0, how I should solve it, I explained in a different way. For a b equal to 0 1, I showed it in a different way, so that you can understand better. Okay. Let me see in how many ways I can solve. Actually, there are multiple ways you can solve this. But yeah, these are all some of the possible ways. From the equation also you can find. Okay. Let's say what you can do is you can say for a b equal to 0 0. Okay. We have mux in of 0 equal to c plus d. Now you can say if c equal to 0, output is d. If c equal to 1, output is 1. So it's like 1 plus d is 1. Okay. So if I just show you the solution, if c equal to 1, output is 1. So if you see, if c equal to 1, output is 1. Otherwise, if C equal to 0, output is D. Okay. Now you can prepare the same in tabular format. A B equal to 0, 1. Mux input of 1 equal to mux input of 1 is 0. So if C equal to 1, what do we have? Output is 0. If C equal to 1, if I put C equal to 1 here, there's no C. Output is 0. If you put C equal to 0, still 0. Okay. Now what we do here is we say A B equal to 1 0. Okay. Mux input of 2 equal to how much? Mux input of 2 is D bar. I showed you previously. In this case, what you do is if C equal to 0, you put C equal to 0 here. What do you get? T bar, because there's no C. In this expression, if there is C, just put C equal to 0 and see what happens. C equal to 0 means D bar. If C equal to 1, then also D bar. Okay. Because there's no C, there's no change. A B equal to 1 1 means mux input of 3 equal to CD. Okay, now we have a C. So put C equal to 0. If you put C equal to 0, output is 0 0. And if we put C equal to 1, we get D. Right? This C equal to 1 column, this C equal to 1 column, you can see on the left hand side. If you see, this is that column. 1 0 D bar D. If you see 1 0 D bar D. And this left column that you can see here, that is present here. No? D 0 D bar 0. Got it, right? This is also how you can visualize this. Okay. I mean, I don't know why it is saying incorrect. Success only. Okay. Maybe last time we had incorrect or something. I don't know. But yeah, it's a success. So, okay. So let's go to the sequential logic part. Latches and flip-flops, D flip-flops. Okay. The D flip-flop is a circuit that stores a bit and is updated periodically. It is a circuit that stores one bit and it updates periodically whenever the clock becomes high. Clock goes from 0 to 1. That is called the rising age of the clock. When the clock goes from 0 to 1, that rise, that rise is when this circuit gets triggered, and then it checks what is the input of D and gives that input to the output. Like it becomes transparent, which means the input gets connected to the output. Okay. At the usually positive edge of a clock signal. Usually positive edge of a clock signal. Okay. D flip-flops are created by the logic synthesizer when a clock always block is used. D flip-flops are created by the logic synthesizer when a clock always block is used. Okay. A D flip-flop is the simplest form of blob of combinational logic followed by a flip-flop, where the combinational logic portion is just a wire. Create a single D flip-flop. Okay. What you need to do is use a clocked always block because we need a clock, input clock. Okay. We'll say always at the rate start, begin, end. Now what we need to give is not always at the rate posage of clock. At that positive edge of clock. So what we do is we take the positive. So you see this arrow says it is the edge thing. Okay, that edge. What we will give is Q equal to D. Q. Now this is called as a non-blocking assignment. Clock always block should use non-blocking assignments. Okay, this is called a non-blocking assignment. I'll teach you this later. So what happens is if you execute multiple statements like this at once, they get executed parallelly. Okay. So let's submit. Here we don't need to give assign statements. Okay. It's a success. Okay. So we have just started the uh, sequential circuits. So let's continue this series in the next class, in the next video. Okay. So try to solve these questions yourself first. Okay, and then try to follow my walkthrough. I hope these walkthroughs are valuable for you. Okay, if they are, please do like this video, share it with your friends, and subscribe to this channel. Also share the playlist. You can watch the other videos as well based on whatever problems you are solving or you got stuck. So if you have a better solution, also please post that in the comment section. If you can answer someone else's question in the comment section, if you no, please feel free to participate and interact. It would be very helpful. Uh, okay, and be a part of the community. If you have any doubts or want a one-on-one session with me, some kind of guidance or counseling, because I'm in the industry for around 3.5 years, so I know a lot of things. It's been more than 3.5 years to be exact. So it's like more than 3 years, 6 months I'm in the industry with leading companies, VLSI companies like Intel and Synopsys. And also I did my masters from IIT Kanpur and I was a topper there. So I have good knowledge, good credentials, good track record. So if you want really good guidance, especially related to the you know VLSI domain, okay, please do contact me. Okay. Uh, so thank you. Thanks a lot. And see you in the next video where we will cover then from the second video on second problem onwards with related to D flip flop. Okay. Thanks a lot. Bye. See you in the next video.